Okay, so we've just had our look in the first video at our first two-step equation, and I just want to put in writing some of the things that we learned here. So, number one, our goal is to isolate the variable. Actually, I'm going to call it isolate the unknown. Okay? That's our goal. So that means we want n equals something, or x equals something. Okay? That's one. Now let's move that over here. And our next goal, or how we're going to do this, is that eliminate constants by constants and coefficients. Tell you what those are in a minute, by using the opposite operation with the same number. And in a minute I'm going to do a, oh, it's unfortunate that that didn't. I wonder if I do this. I wonder if I do that and I return, will that do anything at all? No. All right. Well, that's too bad. I'll talk about coefficients in a little bit. And the next one is you must do on the right whatever you do on the left of the equal sign. And that was number 3, even though I forgot to write it. Okay? So let's take a look at a different equation than the one that we have. And then this time let's maybe do some negatives. Okay? So pick up the pen here and we're going to write 3x minus 2 equals 16. Okay, so now I'm subtracting instead of adding that 2. Now the constant that I mentioned is the number 2. That's the constant. Okay, the coefficient is the number that you're multiplying the variable, the unknown by. So in this case, the coefficient is this 3. So we need to eliminate those things, and we do that by using the opposite operation. Right? And the last thing I should write down, just because I said it in the last video, and we need to see it again, is work from the oh my goodness, outside in. What does that mean? That means that we're going to, if we're choosing here, which of these are we going to eliminate first? We're going to say that we eventually want to get to the variable. So which of these, the 3, the coefficient 3 or the constant 2, is furthest away from the variable, or the unknown rather? It's the 2. So we're going to work from the outside, and then we're going to work our way in closer to the unknown until we have the unknown left there. Okay? So let's take these rules and watch them again with this particular problem. Okay? Here we go. So 3x, 1, 2, 3, and we're subtracting 2, so I'm going to have 2 negatives. And on this side, I'm going to have 16, 1, 2, 3, 4, 5, 6, 7, 8, and I'm just going to double that, and there. Now I have 16, okay? So, now here we go. We want to get rid of this negative 2 first, okay? So opposite operation, same number. So that's going to look like, well, 3x minus 2. The opposite operation is adding, and I'm going to add 2 because it's the same number. So what does that look like over here? Well, I'm going to grab 1 and 2, and I'm going to add them there. And I'm going to take a look at my my rules here. Isolate the unknown. Well, I'm heading in that direction. Eliminate constants and coefficients by using the opposite operation with the same number. I'm doing that with the 2. You must do on the right whatever you do to the left. Okay, so I just added 2 to the left, so now I'm going to add 2 to the right, both in the equation and in my model. There we go. Okay, great. So I'm going to simplify before I go to the next step here. So I'm going to simplify by making my 0 pairs. And when I make those 0 pairs, they go away. So we just saw it, that 2 negatives paired with 2 positives produce 0, and they disappear. So we can just think of these as being eliminated, because when you add 2 to a number, or rather when you take 2 away from a number, but then you add that 2 back, you end up with the same number, which in this case is 3x. And over on the other side, it's a bit easier. I had 16, I added 2, and now I have 18. Okay? Now I'm running out of space here, so I'm just going to copy this up here. 3x equals 18. Okay, so now I need to go back to, am I isolating the unknown? Well, I'm getting there. Eliminate constants and coefficients. Well, I have a coefficient left, so I need to use the opposite operation with the same number. So 3x means x times 3, or 3 times x. So I'm going to use the opposite operation, which is division, same number, which is 3. On the left side and the right side, I'm dividing by 3. What does that look like? Well, I'm going to hit my 3 button here, and now I've got 3 sections. So I'm going to not use the marker. I'm going to not use the marker. There you go. I'm going to move an x into each of these 3 sections. Now I need to move equal numbers of ones in each of these sections, because when you divide by 3, you divide into 3 equal parts. I'm making thirds here. So if I'm taking a look at this, I see that over here, one of these x's is paired up with 6 ones. 1, 2, 3, 4, 5, 6. And the same is true with each of the x's. So 3x put into 3 groups makes 1x per group, and 18 put into 3 groups makes 6 per group. So right now I'm feeling pretty good about my answer. It is x equals 6. But I need to check it. So I'm going to check it, and how am I going to do this with very little space? Well, if I go back to my original equation, I'm going to do this in green. I'm going to try to write small. 3x minus 2 equals 16. Now, I don't really need to simplify anything on the right because it's already as simplified as it can be. So I'm going to work on the left. So 3, and here I'm going to substitute what I think is the value of x, which is 6, minus 2. Now I'm using order of operations. 3 times 6 is 18. Running out of space here. Minus 2. And 18 minus 2 is, I'm going to squeeze that in over here. I know this is sloppy, but I apologize. Is 16. I have 16 on the left side, and I have 16 on the right side. So I'm a happy person. My equation, I've solved it. The answer is x. And now I can get on with my life.